Hello, let me explain a problem. So the problem is draw the equivalent mechanical system of the given system. Hence write the set of equilibrium equations for it and obtain the electrical analogous circuits using Fe analogy and Fi analogy. So before writing the analogy expressions, so let us write the equivalent mechanical system here. So in this problem, there are two displacements. One is for m1, that is x1 of t, and the other one is x2 of t. So let me write these two displacement as nodes. So x1 as well as x2. There are two nodes. Okay. So because we have two displacements. So after writing the displacements as a node, now the mass m1 is under the displacement of x1. So that is why I will write m1 under x1. So this is m1. Okay. Then b2 comes in between x1 and x2. So that is why b2 has to be written in between x1 and x2. Okay. Now m2 is under the displacement of x2. So m2 will be written under x2, that is m2 here. Okay. Now k, one end of k in this system, one end of k is supported to connected to rigid support, other end is connected to m1. So k is also having the displacement of x2. So that is why k is also connected to x2. Now you see b1 damper b1. So one end of that is connected to the fixed support. So other end is connected to m1. So it is having the displacement of b1. It is having the displacement of x1. So it is also connected to x1. Now we have the force f of t. So let me write it because f of t is applied to m1. So you write f of t over here. Okay. Okay. Now this is the equivalent mechanical circuit. So here we have V2. So this is the equivalent mechanical network diagram for the given problem. Now let us write the mechanical differential equations. So differential equations for equilibrium equations for the given problem. Now let me take it for the node x1. So if we write it for the node x1, so we have the mass m1 and b1, damper b1, and b2 will be connected to x1. So it is, so while writing the differential equations, that is m1 into d square x1 dt square plus we have b1 damper, so b1 into dx1 by dt plus we have damper b2, so that comes in between x1 and x2, so that is why it is dx1 dt minus dx2 by dt is equal to f of t. So this is the expression for the node x1. Now let me write it for node x2. So node x2, for node x2 we have m2, k and b2. So m2 into d square x2 by dt square plus we have k, string k. So for k it is k into x2 plus we have b2, again b2 is also connected in between x2 and x1. So it is b2 into dx2 by dt minus dx1 by dt is equal to 0. So this is a differential equation for both the nodes. Now let us write Fe analogy. So Fe analogy, for Fe analogy, first let me write, so F is analogous to voltage, force is analogous to voltage, and mass M is analogous to inductance L, and damping coefficient B is analogous to resistance R, then spring constant K is analogous to the reciprocal of capacitance C, and X is analogous to displacement is analogous to Q. Then we have X dot, that is dx by dt is analogous to, I can write it for I, current, and d square x by dt square is analogous to di by dt. Okay. Now after writing this, let me write the analogous expressions for the given two mechanical expressions. So m1, so m1 is nothing but here m is analogous to L. So it is L1 into di by dt Now again plus we have b1. b1 is r1 into dx1 by dt. So dx by dt is analogous to I. So that is I1 plus b2. b2 is again it is r2 into we have dx1 by dt, that is I1 minus I2 is equal to f of t. f of t is nothing but it is f is analogous to voltage. So that is v of t. So this is the FE analogy expression for the first differential equation. Now let me write it for the second expression, that is we have m2. So m2 is nothing but L2 into d square x2 by dt square. d square x2 by that is di2 by dt plus k. K is analogous to C, that's 1 by C into it is x2. So x is analogous to q, that is dx by dt is analogous to I. So if I take for x, that is integral of I to dt plus b2. b2 is nothing but r2 into dx2 by dt, that is dx2 by dt, that is I2 minus I1 is equal to 0. So these are the two equivalent expressions or else FE analogy expressions for the given two mechanical expressions. Now similarly let us write the expressions for expressions in F5. Let us write the expressions in F5 analogy. So for writing the F5 analogy, so what is F5 in F5 analogy? F is analogous to I, M is analogous to C, B is analogous to 1 by R, K is analogous to 1 by L, X is analogous to phi, dx by dt is analogous to V, d square x dt by dt square is analogous to dv by dt. Now we have the expressions for the first x1. We have the expression as m1 into d square x1 by dt. So m1, that is c1 into d square x1 by dt square. d square x1, that is c1 into dv by dt plus we have b1. b1 is nothing but 1 by r. So here I have to write 1 by r1 into b1 into dx1 by dt. So dx1 that is v1 plus we have b2 into b2 is nothing but again here 1 by r2 into it is dx1 by dt minus dx2 by dt, that is v1 minus v2 is equal to f of t. f of t is equal to I of t here. So that is the expression in F5 analogy. Then let us write it for the second expression, that is m2 into d square x2 by dt square, that is m2. m2 is c2 into dv2 by dt plus we have k into x2. k is here, k is 1 by c. So 1 by c into it is x is nothing but, so dx by dt is analogous to v. So x is integral v of v dt. x2, that is why it is v2 plus dt plus so it is 1 by L. Okay. Next we have that is b2. So b2 as b2 into dx2 dt minus dx1 by dt. b2 is nothing but 1 by r2 into, So dx2 by dt minus dx1 by dt, that is v2 minus v1 is equal to 0. So this is the Fi analogy expression for the given problem.